So we have a short video lesson on powers and roots. Before we do, however, I just want to recap what the multiples of 3 look like. The multiples of 3 are 3, 6, 9, 12 and so on. But you can also go back down the multiples of 3. So basically the multiples of 3, you're adding 3 each time as you move up the family. If you come back down the multiples of 3, you're subtracting 3, subtract 3, subtract 3, subtract 3, subtract 3, subtract 3, so on. So the multiples of 3 pass through 0 and then go negative, okay? But now we get, just to make a distinction, we're now going to look at the powers of 3. And that family of numbers, although it's based on 3 again, is very, very, very different. So what happens with the powers of 3, so there they are written up in their sort of power, with a power notation, with a little power number. 3 to the power of 1 is just 3 by itself. 3 to the power of 2 means 3 times 3, and 3 times 3 is 9, 3 multiplied by itself. This 3 cubed, 3 to the power of 3, means 3 multiplied by itself 3 times. So 3 times 3 times 3, which is 27. And what is happening here is you're just multiplying by an additional 3 each time. So what it means is going from there to there, you're timesing by 3. If you're going to 3 cubed, you multiply by 3 again. 3 nines are 27. If you go to 3 to the power of 4, you multiply that by 3 and you get 81. So as you move up the powers of 3, you are multiplying by 3 each time. So very, very different. With the multiples of 3, you are adding 3, but here you are multiplying by 3 each time. What this means is when we come down the powers of 3, go divide by 3, divide by 3, divide by 3. The next one, if you take 3 and divide that by 3, you get 1. So the number that goes there has to be 1. If we continue to divide by 3, a whole 1 divided by 3, or shared between 3, is a third. And if you take a third and you split that into three equal bits, you get ninths. And if you split that into 3 equal bits, you get that, and then that, and so on. So what we've got here is a pattern of numbers that is very different from the multiples of 3. This is the powers of 3, and you're going up the family, you're timesing by 3 each time. Coming back down the family, you're dividing by 3. The central one is this one here. 3 to the power 0 has to be 1 to fit in with the pattern, and we have a certain kind of symmetry here. If that's some kind of mirror line, then there's symmetry between this and this, between this and this, this and this, and this and this. So if you know that 3 to the power 4 is 81, then 3 to the power negative 4 is 1 over 81. 3 to the power 5 will be 243. 3 to the power negative 5 will be 1 over 243. So just in case you're asked to find a square root or a cube root, so squaring will take you from 3 to 9, and what brings you back from 9 to 3 is square rooting. What takes you from 3 to 27 is cubing. What brings you back is cube rooting. So you have powering one way and rooting bringing you back the other way. If you're asked for the square root of 49, that means what number would you need to have here so that if you square it, you get 49. So that's going that way is squaring, coming back is square rooting. The only number that can go there is 7. If you're asked for the cube root of 8, then that means what number needs to be here so that when you cube it, you get 8. And the number that you need to times it by itself to create 8, the only number that fits that is 2, because 2 times 2 times 2 does make 8. So the cube root of 8 is 2. That's the number that should be there. And that will probably do for now. Thank you.